Hey, sixth graders. Today we're going to talk about the difference between factors and multiples. Factors are numbers that go into a number. Like if I'm looking for all the factors of 12, they're all the numbers that go into 12. So evenly. So we might make a factor rainbow. We've practiced with that. Or we might take those factors and continue to break them down using a factor tree. So that's what a factor is. Factories make products. Multiples are products. So a factor times a factor equals a product, and both of those factors would be multiples. So the hardest part about that is remembering which is which, but we use them for a little bit of different things. We use factors to reduce fractions. Like if I have a fraction like 2/4, I can see that 2 is a factor of both 2 and 4. So 2 goes into 2 one times, 2 goes into 4 two times. So that's one time that I use factors. So, and that's the very immediate to us because we're doing fractions next. A multiple, we have used, multiples are numbers that other numbers go into. Like the multiples of 2 are not numbers that go into 2, but they're 2, 4, 6, 8, etc. So 2 times 2, 3 times 2, 4 times 2, 5 times 2, all, and these go on forever. So you can see that the number like 12 is going to have a finite number of factors that I could get with a factor rainbow, and a number like 12 or any other number is going to have infinite number of multiples because it's just however many times I choose to multiply it. And one of the times we use those are when we add or subtract fractions. So we need to find a common denominator. There's that word common. We have GCF, greatest common factor, and LCM, greatest common multiple. That means they have them both. So we need a number that both 4 and 2 go into, and we're going to decide that that number is 4. That's the least common multiple. It's the smallest number that both 4 and 2 go into. So I can just write my 4 right there. And now I'm going to see, I'm looking for factors. How many times does 4 go into 4? Once, so 3. It goes in there 2 times 2, so times 2 is 2. So just like when we're converting over here, exactly the same. Now I've got 2/4. Let's say this is plus. 3/4 is 5/4. 5/4 is 1 with 1 out of 4 left over. 5 divided by 4 is 1 and 1/4. So we use the least common multiple, or at least common multiples. It doesn't always have to be the least common multiple. We use it when we are adding and subtracting fractions, but also when you are trying to figure out, like problem number 20 in our book, how many packs of hot dogs, because they never make the packs of hot dogs that match the packs of buns. How many of something that repeats? So that's when you use multiples. And if you want to spend the least amount of money, then you might be looking for the least common multiple. They have us doing it in a couple of different ways. One is for Venn diagram, which we used in when we were finding factors as well. So if you're looking for common multiples of numbers, I'll just do 3 and 4. I think that's even in your book. So multiples of 3 are 3 and 6 and 9. And you see they're going to go on forever, right? Multiples of 4 are 4 and 8 and 12. Well, wait, I got 3, 6, 9, 12. So 12 doesn't belong in the outer circles. 12 is actually a common multiple. So I can see there's going to be other multiples too, like 12 and 24, and it's going to go up. But 12 is the least common multiple. So you can use Venn diagrams to find the common multiples and the least common multiple. That's not probably the way I would do it. For me, I would just make a list. I would say 3, 6, 9, 12, 15. Well, let's try the 4s to see if anything matches. 4, 8, 12. Oh, look, something did match. So for me, that's easier. They have another way that you can do it in their section 2 of this lesson, they talk about prime factorization. So, well, this is kind of an interesting one. So if I was going to make a factor tree of 3, well, it's just 3 and 1. So there's no factor tree, right? Because 3 is a prime number. But if I was going to make a factor tree of 4, it's 2 and 2. So I'm going to take all the factors, the prime factors here, which are 2 and 2, and the prime factors here that don't overlap, and I'm going to multiply them together. 3 times 2 times 2. 3 times 2 is 6, times 2 is 12. So there it is again. And it's this kind of a fun and interesting way. You can do it that way. This is my way. But once again, we learned math. It's the way that you like best. So I hope you enjoy this. This is something that comes up. We're going to use a lot in fractions, but also when we have picnics in the summer for we buy hot dog buns. So I hope you enjoy least common multiples.